Okay, this video is going to discuss how to differentiate a log expression. Okay, very quickly, just this graphic here. What symbol do we use? Um, please don't use log, which is base log, base 10, but instead use um, natural log. So which button to choose? Are you stressing over it? No, from now on, log in your brain here, the natural log function. Okay, so uh, speaking of information that you're given or formulas, click on this thing here, and obviously the second page in, and here's the table. It's the front row, natural log of x. That's the function. If you differentiate it, well, it gives you this expression here, 1 over x. Okay, so the question here is, do you know, it doesn't actually state it here, but do you know what a natural log graph looks like? Okay, if you click on this app here, I'd like to thank Mr. Tim Brunitsky. Apologies, I mispronounced your name there. But this is really good. Okay, so what you're seeing here is a natural log curve, similar, I guess, to a log curve. Yeah, okay, we're just going to stick with this. So a log curve, basically, it's when x is 0 on your graphing calculator. If you go natural log, find the natural log button, natural log of 1, the answer would be 0. If you go to this value here, for example, about here somewhere, natural log of 7 something, the value would be 2. Okay, interesting enough, if you go between 0 and 1, the value is negative. Okay. Yep. And you can't have a negative log. Now, hopefully you understood that from your year 12 algebra experience. Okay, just while I've been playing with this, you may have noticed it's drawing these blue dots. The blue dots are so that the black line is your function curve. There it is, natural log. The blue line here is your gradient curve. Okay, let's just think about it. Okay, this value here. Now, go back. Let's go back the other way, actually. Let's go back to here. Okay, so the function is natural log. The derivative function is 1 over x. And did you see that in the expression here? If we put this in. So as natural log of x, 1 over x, it's getting smaller. Can you sort of see it's getting smaller? In fact, 1 over a very big number is small. But if you go here, okay, this is interesting. When x is 1, 1 over 1 is 1. That's why the curve, and smaller, 1 over 0.5 would be 2, 1 over 1/3, etc. So the relationship is the natural log curve is here, and its derivative function is described by 1 over x. Okay, that's enough. So hopefully that has shown you that graphically you can sort of see that relationship happening there. So how to learn this? You're going to have to use the chain rule, and Tahi Maths here is very good. This video gives you a couple of examples. This is subtle log properties. In particular, these skill sets, those three there. And if you're gunning for a merit or excellence in the external, I would encourage you to be aware of the little techniques you can do with logs. Now, I'm hoping you had that explained to you, but I will, every opportunity, if I can see a wee log thing we can manipulate, I'll be doing that in the differentiation course here to show you those skill sets. So yeah, that's definitely worth watching, especially if you're gunning for a merit or excellence. Okay, STEM Online, click on here, and it's option number 5. We're still under basic rules. Is the words they use there in STEM Online. Practice makes perfect. Okay, so there is a few problems, not quite 30, 27. I've got here 6, which I've random selection. Have a go at those. Look at my answers. Have a go at them first. have a go yourself. Check your answers on New Lake, right? And the key thing here is if you get stuck and you've checked your answer on New Lake, it could be how New Lake has presented its answer. Your answer is probably correct, but not in the format that New Lake wants it. So anyway, send me an email if you get stuck on a problem, and basically most likely I'll say, hey, this person's requested number 139. Here it is, and it's the first thing we'll do in a Wednesday VC session. Okay, I'll say, look, I've got a request for this, so please don't be shy and do that. As the bottom here, feedback, and there's no memes for this one. If you can find a funny meme, calculus related to natural logs, please let me know. Or please send me an image of it and I'll verify it and stick it in.